All right, welcome back, generals, to another Let's Fix the General Zero how to make the best game ever. What are we doing? We are working on some tool that we have no clue where we're going with this. Well, that's promising. Well, that's not it. That's it. Okay, so Mr. Omniblade has written. In regards to the unrecognized opcodes, he wrote that is probably a reading frame issue because x86 opcodes are variable length. The same bytes can be interpreted differently depending on where you start reading, because functions can be alignment padded. Just straight reading the whole text section and trying to disassemble it will fail. The code needs to know where functions start and end and what to do between them. First pass is to locate jumps within the code, so relocation within the same function can be labeled up correctly. Okay, this makes sense. So perhaps if we actually just read function by function, as we have done in the video prior to the last one, perhaps we don't run into this fail here. So how about we put breakpoints here? Yeah. Then we go to our main function. And then we say we go here. Disassembly function. Abort if we can't output anywhere. How about we say how about we allow how about we allow run this code without actually writing to a file, which would make it more efficient for debugging purposes. I mean, yeah, effectively it makes sense to, like in real case, only use it when writing out to files, but for just debugging, I think it would be nice if we could not do it. So how about we remove this and output, we say if output's not null pointer and not sim empty, then write that bitch. Yeah, maybe we can do that. Yeah, then let's remove this, and then we go to main and we say fp. Let's create here a define write to file one, flip to 0 to just run code without writing files. And then we'd say if write to file, then do all this. FP. Perhaps we can take this out of the function. But there's a lot going on here. What is this? Output could be 0. Yeah. Oh, right. I made a mistake here. We need to say if. Yeah. Oh. I think that's the right thing. We have a mistake here somewhere. Okay. Well, let's just say if that, then do this. Else, just call this with an null pointer. I guess that's simple enough. And we set that to 0. And so then it won't enter here. And that should be working. Okay, then, so now it will just walk through all the code for all the functions, but it won't actually write the file out. Okay. Okay, but it still hits. Look at that. Okay. Okay, let me actually check that it actually goes through the correct codes. Oh, it doesn't. All right. Okay, so we need to remove this. So so it needs to go through this code here. Aha, but it still hits. Yeah. Okay, let's double check that we're definitely in the right. Yeah, we are in here. So this one is definitely going through the right things. Okay. Okay, this is a very early function already. Unrecognized opcode. Okay, let's see if we get more hits. Yeah. We get more hits. We get a lot of hits. Yeah. Okay, then I think it would still be interesting to log these out because it disproves what Omniblade has claimed, that this only happens if you read it like in an unordered fashion or in an invalid fashion. But this time we are certainly just reading with a given start and end points of the functions. So by his accounts, it should not happen, but it does. So perhaps we should log out this. I'm actually curious that it's so early. Like we are not far off, right? Like it's just a really small number. What function is this? Create dynamic memory allocator. Okay, how about we okay, how about for starters, we just count how many there are. If there are also close to 1700, then perhaps it's just the same things. Let's add a counter here. Int counter 0. Yeah. And put plus counter here. And here. Let's do a remove. Actually, we can put it into this function here. Plus counter remove. So, but the problem is we can do printf printf percent %d counter. So we just printed the terminal just to see how many there are. Let's see. Okay. And let's let it run. Yeah. Yeah, 800, 900. Yeah. Okay, it's less, but it still happens. Like around the 1,300 looked like. 404. Okay, let's write a reply. I tested this by walking through all the functions that Thompson's has provided. There were still around 1,300 hits. Less than before, but still happens. So it does seem that some opcodes are not recognized. The way the code handles it now is simply by skipping those bytes and continuing afterwards, which appears to be those bytes dropping or dumping a comment and continuing with the next codes. This appears to be working okay. By letting it walk through all the functions that Thompson's has provided. There were still around 1,300 unrecognized opcodes. Less than the 1,700 before, but still happens. So it does seem that some opcodes are not recognized. The way the code handles it now is simply by skipping those bytes, those unrecognized bytes, and dumping a comment and continuing with the next codes. This appears to be working okay. It's just a few hundred opcodes in 2 million lines of ASM. Okay. Yeah. That is okay. Good. Then I would say, should I maybe, are we interested in a lock of, in a new lock of these unrecognized opcodes or not? Okay, then add base. Then let's merge what we did now to get the stuff clean. So we can remove this again, this counter. So basically we just dump now the unrecognized instructions as a comment to just have it documented that there was like an unrecognized thing. I mean, when we do like a comparison, then we just skip this comment, right? It's easy, no problem. Loops for function once. Da, da, da. Then this is samples. Okay. Okay, let's get here. Let's first submit this one. Write to file. Okay, so that's in main. Actually, perhaps we should make it a command line. So if we put a there is an output. How about output? Output. This is very confusing, yeah. Opt arc. Okay, I wonder if we can do it like so that if output is empty string, then we just don't output, you know? So this way we wouldn't need like an extra command, but how do we implement that? Because here it's not using the output. So basically, if file name and file name, then do this, else do that. Oof. This. Boy. Boy. Yo. The formatting is just wild. Whenever I edit, it just falls apart. Okay. So I think this will work. So if we give it an empty file name, then it will go in here. How about we do auto? We put auto in here for automatic, yeah. And if it's, and let's put a comment here, program.s. So if it's auto, then we put here if str compare output auto, let's do const expro, or just const char const auto output is auto, yeah, and then we put it here. And then we say here auto if this auto output, let's do std string output initialize with, let's do O. And initialize with output, yeah. If, let's do if O is auto output, then we put actually well, then let's go back. Okay, if 0 is that, then let's not initialize O yet. So if it's auto output, then O is equal here this plus dot s, okay? Else O is outputs, okay? Then we do here O dot cstr, okay? So basically, it instead of program.s, it will then do game.dat.s, right? So keeps the name. I need some water. Okay. So okay, so automatically we choose this, otherwise we choose that. And here, dump function to file. So here, if let's put a file name here. Maybe that's better name. File name. Yeah. Okay, and then we copy this here. Put that here. And we say function file name. File name. So auto, we do this, and otherwise, yeah, how do we do it the otherwise? We do output, we do output plus dot yeah, I think that's fair. So then someone would have to supply yeah, I think it's fine. It's not ideal because you don't have full control in this case over the file name. It's still modified, but I think it's okay. Yeah, it's fine. Okay, and then we put this here. Yeah. Okay, so what this should allow us to do is, if we now put minus output empty, then this should work. Let's see. Perhaps we just make a pass here, std string. If not file name dot empty, f open file name dot cstr. Yeah. Okay. Let's see. Okay, so this, okay, it's empty now. Yeah. Okay. Hold on. So this one will fail, but here it will now do empty dot. Okay. How about we say here, if output well, we can do it like this, yeah. We just compare it with the empty string. How about that? Empty. And put here else if okay, let's put this here. Okay, and then we can, yeah, so now it's empty and it goes into dump file eventually, yeah. File name is empty, and so we will disassemble without writing out, yeah. Okay, good. Then that's good. Let's check if write out still works otherwise. So it's auto. I added now support for letting code run without actually writing 200,000 files, and can put breakpoints where it fails. So it's now easy to debug and find. Good. Yeah, let's see if it still writes out file. So we put here this, remove this. Let's delete the file first, program.s. Let's delete. Okay. Let's run. Okay, now it's called game.dat.s, and it is writing. Yeah, okay, has written. Okay, good. So I think this means we can remove this, and let's go back in here. So I put that. Then we have file name. Here we can make some more change. So we no longer pass as CSTR because it would construct a new string. We do this. Right. Okay. So let's make a comment here. When output is set to auto, then output name is chosen with input file name. Is chosen for input file name. Yeah. Maybe we make this comment here in a new line. The section name thing is unused now. Pretty much. Yeah. We don't need to remove it yet. Let's just comment it unused. Well, actually, in that case, we can also put the comment here. If all the other comments are also at the end of the line. So exe file name I do wonder what happens if there is no exe file name. What happens then? Let me see. So you remove this, what happens? Let's see. Well, it's null. And this will crash. No, it doesn't. Not yet, at least. Okay, well, it will crash here. Uh-oh. Yeah, there we go. Okay, so that is totally unhandled. So we say if X file name is null pointer or X file name 0 equals 0 character, then missing input file aborting or exiting missing input file command line arguments. Okay, let's see if that hits. Oh, we didn't put a return. Return 1. It looks like it turns -1. Okay, let's see. Okay, so that is fixed. Good. Then let's go here. Output. So we need game.dat and then it will work again. Okay, let's start committing now, finally. Let's make this a separate comment. Commits return program if input file is missing or input file is it probably will still crash if input file doesn't exist, maybe. I don't know. Return program if input file name is not passed in command line. Okay, next is here output. How about we rename this FP? Here, because we used output already for this other name. So maybe we should use here fp, consistent variable names. fp here, fp, fp. Okay. Okay, so yeah, I think that is okay. And they take this and we can also take this. Maybe not. Let's unstage that. Okay, so we take this and we take that. How about here? Let's go back to main. How about we put output close to auto output? Yeah. Okay, this should be working. Executable. Yeah, let's compile once more before we submit that. Yeah. Okay, so this is, what is it doing? Allow change output argument to auto by default. Allow empty. Allow running this assemble without writing to files. Disassemble without writing to files. Auto and implement file name building. Implement automatic file name building. Allow running disassemble without writing to files. Okay, did we do any mistakes? Hopefully not. Okay, let's commit this. Okay, then we stash this and see if it still compiles as is. It does. Okay, good. Then we unstash. And then the next thing is we made a change here together with this here. Here, these things. So that is improve this disassemble disassemble address address, building, and conditions. I don't know. Okay. Let's stash. See if it compiles. Okay. Stash pop. Then next we do this here. Perhaps we should improve this function name here. It's kind of wild. Why is it not finding it? Oh, by the way, this one should have been in the other change. Okay. Okay. This function here. Do we have a better name for this? Create unrecognized instruction string. Create unrecognized instruction string. How about call this build? Let's call this invalid, maybe. Build invalid instruction. Yeah, I think that's fine. Okay, stream fair, address, X runtime, bytes. Stream. Yeah. We can actually how about we do so basically there always will be excess white space at the end. Can we perhaps, I mean, we could always say, okay, if length -1, then don't append it, but it's a more elegant way. If we would post it at the beginning, then we would have a gap between bytes and the first. Da, da, da. Bytes. Maybe it's fine to just post the bytes without any spacing. Let's do if if I bigger larger than 0, then stream space yeah, I think that's fair. Okay. Good. Yeah. Then we say here skip or continue. Yeah, no, skip unrecognized opcodes and skip unrecognized opcodes. Print information about it and continue disassembling afterwards. Why is this afterwards? Why doesn't it know afterwards? It's not a valid word. Afterward. Maybe it's not plural. I don't know. Afterward. Skip unrecognized opcodes, print information about it, and continue disassembling afterward. Okay. Then that should be good. All right, let's see if it still compiles. Yeah. Good. Yeah. Okay, so let's push what we currently have. Pushed current changes. Okay. Okay, so we have made a little bit progress here. Okay, so we need to now figure out next step. So what are the next steps? I assume we need to get. I assume we need to get file. We need to get ASM files for self-compiled program. Need to generate ASM files for self-compiled program. So we take Thompson's, what is it? PDB dumper, try to integrate it into unassemblize to where we can generate the same kind of outputs. Yeah. And then perhaps we can use PDB info to iterate CPP file symbols, find the relevant functions, inside, bundle them, and then generate ASM for these bundled functions in both Thyme ng and game dot. Yes. And then when we have this, we can think about how to cleverly compare these, unless we need to clean up more differences in the ASM first. Yes, that's my just putting thoughts. I don't know. Yeah, so I'm not sure if that is a correct approach, but that would be my thinking now. So we have the PDB dumper, which basically allows us to, so it has, the PDB has a symbol discovery, symbol database for the executable that we compile. Yeah, so it allows us to iterate over symbols and discover all, like the names and where the code starts, where the code ends, all this stuff. And then we take this and we also put it into unassemblize and also generate the same kind of ASM data. So that ideally we would have left and right ASM, one from our code and one from original code. And then we got, if we got this and it looks clean, well, let's say it doesn't look clean yet. There's discrepancies in addresses and stuff like this. Maybe it needs more cleanups first, but maybe not. Maybe we say, okay, for the most part, instructions is all we care about. So we compare it and we ignore some things when we compare. Yeah, maybe it's possible. But ideally, let's look at this here. When we look at this, oops. Let's scroll down here a little bit. if it allows us to here. So basically we have this from one program and the other from two programs. And then obviously here it looks like there will be differences, right? So this offset likely won't be the same as the offset in the other, right? Because these addresses will be slightly different. And this probably will also be different. So what will be the same? This should be the same. This should be the same. This should be the same. Or this. So we probably then would need to say, okay, if there is a lock underscore, we don't care about the value behind it. We don't care about off, the value behind off underscore. Yeah. Yeah. Okay, that looks simple. If it's just that. And here, this one, format. Okay, well, this could be the identical. Yeah, if we have the same names, ASCII string class, format function. I don't know if this would match then, maybe. But even this could be matched if it wasn't perfectly the same. Yeah, okay, well, it looks pretty clean. It should be possible to compare this. Yeah. Yeah. Yeah, this is interesting. I hope that this will be the same. Yeah. Also the jumps, like well, these addresses could still be compared by if it's a local jump within the same function, then it can be compared when we take this address minus the function start address, and then we have the offset, and these offsets should match between both versions, left and right. So this address and then the starting address will be something like 11F8 something maybe. Yeah. So this minus the other, and then we have a diff with a smaller number, and then these offsets should be identical, right? Because otherwise it would jump somewhere else. Like let's say this jump would jump here to here, yeah, and not to here. And there would be a mismatch, then we would still need to detect this, right? Yeah. Okay, but this should be possible. What about this other thing with the... yeah, here with jump, yeah? And labels. But there was something else with off here, offset. Yeah, but this one we cannot. This one I don't see happening unless we... I don't know. But I think it's not so important. Like, it's very unlikely that we have major mismatches in these things, because if this is wrong, if this offset is wrong, then everything else afterwards falls apart. I mean, on runtime, and it would just crash and it would be super obvious bug. So comparing this, I think, is not easily possible, but it's also not so important, I would say. So it's probably fine to just skip over this. As long as this matches, it's probably fine. Yeah. 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 Good. Then what's the time? 1 hour 15 only. I have the impression I worked for 2 hours. I don't know. It was kind of intense, but looks like it was not that much work. Okay, but we got a few things done today, which is not bad. Even though I had no clue what I'm doing, we made progress. That's good. Okay, so I guess next step, I wait for some answer here, and hopefully I get some answer. If not, then, well, we are on our own. Then I will look here into the PDB dumper from Thomson's. Yeah. See what's up with that. Maybe we can integrate it into unassemblize. Looks like Psychana already looked into it as well, and he got it to run. He says, I fed it its own PDB and it seems to work. Then I tried a random PDB from Visual Studio 6 and it produced something rather incomprehensive. Yeah. Okay, yeah, but that's a good question. I would also need to build it in with Visual Studio 6. Yeah, but we can have a look at that as well. Yeah. So basically we need an executable, Thyme executable and a PDB so that we have something to work with. Yeah. Okay, maybe we should do this first. Try to get it to compile and like have something to work with. Yeah. Okay. Okay, but I mean, there is an idea. There is an idea, and it looks like there is a way as well. Whether or not it will work, I have no clue. Yeah. Yeah. Good. Then I will quit it for today. Then, yeah. I wish you a great day or night. Until next time. Goodbye.